Attention, the following video is going to totally kick ass.
And go.
A combustion reaction consists of a fuel source, a heat source, and oxygen. Our fuel source is the gas, our heat source is the flame, and our oxygen is in the air.
Yeah.
Voila.
So our next step in making the hamburgers, we're gonna use oil to cook the patties, and oil has a specific heat capacity of 0.4 calories per gram, and it takes 0.4 calories per gram to raise the temperature 1 degree Celsius. So in order for a substance to acquire heat fast, it has to have a low specific heat capacity, like oil.
I don't need to go.
Tell me when.
Though right now, I'm gonna turn on the stove. There. And then we put the pan with the oil on it. So we put the meat in. Then we put the meat. And what's happening right now, it's energy transfer from the stove to the pan and from the pan to the meat.
Alright, now,
Okay, so what's happening right now is energy transfer from the stove to the pan and from the pan to the meat. And this type of energy transfer is called conduction. So conduction means when energy is transferred through contact, and that's what it's doing from the fire to the pan and from the pan to the meat.
now, see, with the conservation of energy, we know that when heat is being transferred, none of that energy is being lost. It's transferring from the fire, and all that energy from the fire is either being dissipated into the air or into the pan, but is then transferred into the beef. Pause. Alright, now see with the conduction, it's transferring the heat, and its heat is still being conserved. So the energy is being conserved through the property of conservation of energy. So when the heat's being transferred from the flame to the pan, to the oil, to the fries, it's all the same energy due to the law of conservation of energy.
With the oil, and as you see, it's starting to cook already. The heat from the pan that was produced from the fire is going to the meat, which is making the fries cook. And then this is a type of energy transfer, which is called conduction. During conduction, energy is being transferred to contact, and this was from the fire to the pan and from the pan to the meat. And yeah.
Alright, now another law that's happening is the law of conservation. Now when the heat is being transferred from the stove into the pan, into the oil, into the burger, all of that heat is the same heat energy. None of it is being destroyed or created. So yeah, that's the next concept of energy.
And then what's happening right now is energy transfer from the. What's happening right now is cooking the meat, and as you can see, it's starting to turn brown because it's cooking, and it's cooking through the energy provided from the fire to the pan to the meat, and that type of energy is called conduction, and that's what's happening.
Alright, now while we're doing conduction, the heat that's transferring is all, it's never destroyed or gained. And that property is called the law of conservation. The law of conservation states that all heat is the same heat. So the heat that was coming from the flame to the pan to the oils to the beef, it's just being transferred. None of it is being destroyed or created. That's called the law of conservation of energy. Right.
So right now we're heating up the buns, and what's happening right now is convection. Through convection, energy is transferred through air, and then right now there's like hot air inside the oven, which is gonna heat up the buns.
Coca-Cola is a liquid. When placed into the freezer, this Coca-Cola would turn into a solid due to the state of matter, and the phase changes. Now, due to the cold temperature, the Coca-Cola's molecules would have slowed down and become rigid, therefore becoming a solid. We did not do that because we want to drink the Coca-Cola. Pause.